I will talk about my final project. So first, I obtained 20th place and 21st place for the public and the private rankings in the code competition. And then I will talk about my code. First, I set up some libraries, global parameters, and I load my data sets. Then just do some EDA. So I plot all the features over time, and I also draw a correlation map so we can see all those features are really correlated to temperature. But this last three and pressure can have really kind of not really correlated to temperature too much. And then I pre-process all those data. First, I need to do normalization. So I use the z-score normalizations by the standard scalar, and then prepare the training data to be keras ready. I use the service to supervised function. This one is defined in the reference website, which Professor shown in this project. And then we can create a reshaped X-chain so that we have 336 columns. That is 14 features multiplied by the 24 hours, because we want to use 24 hours data to predict the 25th hour's temperature. And so next step, we can build up our models. So first, I split the data into training and validation sets because there's no validation sets provided. But we're not able to use the test scores in competition size to evaluate our models, so we have to use validation set to do the model evaluation. I decided to use 33% to be the validation set and 67% the training set. Then I can build my baseline model. First one is just one layer LSTM with 32 blocks with output one dense output with linear activation, and the loss function used is mean absolute error function, and then optimizer just use it Atom. So by 30 epochs and 64 batch size, I can get a validation loss of 0.0585, and with train validation loss plots, it's quite good, I think. And actually, I tried tons of different models, but this one baseline model turns out to be my best model, so I use this one for competition. And I tried stacking LSTM plus one-dimensional CompNet. So, but the results didn't perform better, and also I think using convolutional neural network will make the performance worse. Since we're using time series data, I think CNN is not really good at time series data. So we can see we have a larger validation loss. And I tried the GRU. For GRU, one layer GRU, the result is 0.08, and also using stacking GRUs. So it's quite similar to the LSTM, but I think LSTM has a better result. That's the reason why I just go for LSTM. And there's quite a lot of models I tried, and I tried different number of neural network blocks. So rather than 32, I tried 240, and I tried 250, and I tried 40, and but all those kids had quite similar results, but no one beat my base model. So I had a table that summarized many of my models. We can see base model has the smallest validation loss. So I choose this one to submit. And I can see I tried the bidirectional models, so just didn't perform better, and I used feature selections. So I used rather than 14 features, I used just 10 features selected, but the model is quite similar. So I just go forward with non-feature selected models, and then I just implement the stateful, and also stateful LSTM models would be quite similar to my baseline model, but it didn't outperform, so the result is slightly larger loss. So I just go forward with baseline model. And I also found that if width drop out, then the model didn't perform better. So I just decided not to include dropout. So you can see here for my codes, I implied the baseline, the statefulness, and I just used 239 as a batch size because that is a common factor that I can find for all the validation, training, and test sets. And also modify the size of training and validation sets because I have to find one common factor that can be used as a batch, as a batch size. Yes, and then also I also did some dropout and recurrent dropout, but actually I don't know why it just hurts performance and even generate more overfitting actually. So I decided not to use dropout, and after that I just made the predictions and put that into the submissions CSV. That's it.